we have three main tanks. We have the left wing tank, we have the right wing tank, and we have the center tank. Although on some aircraft we have an outer, okay, and an inner cell, it's a cell. It's part of one tank here and here. Okay. And then we have the center tank. 45 years ago, they designed the A320. They made three main tanks, but they split the wing tanks into outer and inner cells. Outer and inner cells with intercell transfer valves that transferred the fuel one way and the other way. Now, the idea was, when they designed this 45 years ago, was that they would fill the outer tank, the outer cells first. Okay. And the reason for that is because they wanted to keep the weight rigid on the outer parts of the wing to extend the life of the wing. So they pump the fuel to the outer cells first, and they use that fuel last. They used it last. Why? Because when the wing, after takeoff or during takeoff, during the takeoff roll, the wings will bend up like this. Okay, that's when they cause their maximum lift. The aircraft goes up, okay, and takes off, and for the remainder of the time, the wings have an upward bend. It's not visible with the eye unless it's a 747. You can see the wings really bend up, but on a normal 320, the wings do tend to bend upwards when they have a high lift. So what they do is they fill the outer tanks, and the weight keeps the wings down and straight and rigid to prevent this bending, this flexing. And therefore, the idea was to extend the life of the wing like this, to stop the stresses causing cracks, damage, whatever, into the external wing. At a later stage, when the 321 came out, they did away with these intercell transfer valves and the two double cells, okay, because they saw the wing was pretty rigid. It didn't need any filling outboard to inboard first, etc., etc. So there are two variants, okay, between the 318, 19, and 20, in that we have the three tanks, but the wings have intercell inner and outer cells, and the 321 that has three tanks, but no inner and outer cells. Okay. The rest of it is pretty straightforward, apart from these jet pumps. I'm going to go to the classic one because this is the base model, is the 320, and the 320 is this intercell transfer valves. Each tank has two fuel pumps, or what they call boost pumps. And these boost pumps are there to supply fuel to the engines. In normal configuration, the left side, the left boost pumps or left wing boost pumps will supply the left engine, and the right boost pumps will supply the right engine. And if there was a problem with fuel supply at any point, the cross-feed valve in open position would enable the supply of any engine from any tank. Okay, so cross-feed enables the supply from any boost pump or any tank to any engine required. We also supply from the left-hand side through a APU pump, low pressure pump, fuel to the APU, because that's also an engine that requires fuel from the left-hand side. And you can see it when the APU is running for hours and hours and hours, the quantity in the left wing gets less and less and less and less. And then you have a discrepancy. And then you have to transfer fuel from the right-hand side, from the right-hand wing. By opening this crossfeed valve, you enable fuel from this side to come in, okay, and not only supply the left-hand side, but also can supply the APU if required by switching these boost pumps on, opening the crossfeed valve, and switching these boost pumps off. You would then be supplying the APU and also being supplying the left wing from the right-hand tank. Now, these intercell transfer valves, we said, so we fill the fuel in the outboard tanks first, then the inner tanks, and then last, if the flight is long enough to warrant it, we then fill the center tank last. Why do we fill the center tank last? Because over here on this, what I'm indicating now, is all the passengers. Yeah, so the center tank actually goes through the aircraft. It's a tank full of fuel. Okay, so we only want to fill it if required. We don't want to have to unnecessarily fill it if we don't have to. This fuel is external of the aircraft, is away from the passengers. And that's the way we like to have it. So we fill this tank last and we use it first. Okay, for exactly the same reason. It's in the cabin, it's above the passengers. We want to get rid of it first. If there's fuel in this tank, before we start using the inner cell from the wing, okay, until that reaches a certain level. We don't use the outer cells. Why? Because we want to keep them rigid with weight in there. At a certain fuel quantity here, a computer will receive the information, oh, we're reaching critical amounts of fuel now because we need fuel to burn the engines. Give us some more fuel. These intercell transfer valves will get an indication or a command from the computer, open. And they will open and then allow the fuel from the outer cells to come into the inner cell. And the inner cell will then use it for combustion of the engines. That's the whole idea of the system. They moved to the 321 when it came out. They improved in that the center tank uses these jet pumps now as opposed to boost pumps. Okay, but the principle is the same. I'm not going to repeat it all again. It was just an improvement in the system to use jet pumps and do away with these intercell transfer valve, inner cell tanks per wing. Because we have different wing configuration, we also have two different panels. So for the 318, 19, and 20, the fuel panel would look like this. Both got automatic functions, but the 321 would have these center tank jet pumps indications here. Okay. As opposed to no jet pump indication here. So depending on what aircraft you were on, you could actually see from this overhead panel, you could actually determine what type of aircraft you're sitting on. It's a 319, 20, or 21 because of this panel here, this layout. The function of it is identical. We have an automatic function in that the automatic function in this case means that the fuel is commanded to empty from the center tank first, okay, to take the fuel away from inside the cabin and away from the passengers and out into the engines and burn that first. It is also, in terms of stability, I want to keep the wing equal for as long as possible. So I use the center before I start using the wings. So the automatic function enables this emptying of the center tanks first. Once the center tanks are empty, the automatic function will switch the two boost pumps in the center tank off. There's no point the boost pumps turning, in an empty tank, because at the end of the day, the boost pumps are three-phase motors. And three-phase motors cause sparks. And sparks in an empty fuel tank, we know what's going to happen. Boom. Okay, so we want them switched off when the center tanks are empty, and they do that automatically if we are in the automatic mode. If for any reason the automatic mode didn't work, okay, we can manually at any time switch the automatic function off, which means at some point when the center tank is empty, when the pumps are running without any torque because there's nothing in there, then the fault lights will come on, and it's the pilot's cue to replace the fault light with the off indication by switching the boost pumps from the center tank off because the tank is empty. And while the pumps in the wings are on, they will start supplying, each wing will start supplying its on-site engine. In terms of indications, all right, so since we have a different layout, the 318-1920 has its three tanks, but the wings have inner and outer cells. And the 321 has three tanks with no inner and outer cells, and has the jet pumps in the center section. Okay, note the difference. The jet pumps are supplying the wing tanks, whereas the boost pumps on the 318-1920 are supplying the engines. Okay, there's a little difference there in the design because they're on jet pumps. That's their purpose in life, is to feed into the tanks, into the wing tanks, and the layout here exactly as it is on the overhead as you see it. Okay, other parameters we have the fuel temperatures, because it's significant to know the fuel temperature, the fuel quantities, okay, the fuel used, and the total fuel on board. If you can't make all these calculations, the total fuel on board is indicated at the bottom here.